guys, today we are going to study the nature of a composition of two functions. First, we are going to prove that the composition of two injections is an injection. So let ABC be three sets. Let F be an element of b to the power of a. I mean F is a mapping from A to B. Let G be an element of C to the power of B. I mean G is a mapping from B to C. And first we are going to assume that F and G are both injective. And we are going to prove that G of F is injective too. To prove that G of F is injective, we are going to take two elements, x and x prime, in the set of departure of G of F, and we are going to assume that their images by G of F are equal. So we write for all x and x prime that belong to A, the set of departure of G of F, such that their image by G of F are equal. And we are going to prove that x is equal to x prime. We know that G of F of x is equal to G of F of x prime. Hence, we have got G of F of x is equal to G of F of x prime. But G is injective, so if the image of these two boxes by G are equal, we can conclude that those two boxes are equal. So we conclude F of x is equal to F of x prime. And in the second time, F is injective if the images by F of x and x prime are equal. We can conclude that x is equal to x prime. Secondly, we are going to assume that both F and G are surjective, and we are going to prove that G of F is surjective too. Let's assume that F and G are surjective. Let's prove that g of f is surjective. To prove that a function is surjective, we take an element in the set of arrival of the function. I call it y, and I'm going to build an element in the set of departure of g of f, an element whose image will be equal to y by g of f. For each y that belongs to C, which is the set of arrival of the function g of f, such that nothing, and we take so this y, and we are going to build one element here. We must find an x. There exists one x that belongs to A, such that his image by g of f is equal to y. G of f of x is equal to y. So we must build this element. And here we have the body that allows to prove a function is surjective. What can we do with this y? We can first build an element in B whose image by g is equal to y. So this element, I call it z. As g is surjective, there exists one z that belongs to B, such that g of z is equal to y. And now, what can we do with this element z? We can build one x in A, whose image by f is equal to z. As f is surjective, there exists one x that belongs to A, such that f of x is equal to z. And now I can verify that g of f of x is equal to y, because g of f of x is equal to g of f of x. F of x is equal to z, and g of z is equal to y. So I found one element in A that is called x that has the property g of f of x is equal to y. Bye bye guys.